Those are online. Are you able to hear me?
Yes, sir.
Get started. I'll edit the control. Right. Yes, I will. Off. இப்போதைக்கு ஒரு 5 minutes நீ ரெக்கார்ட் பண்ணிட்டு நான் அதை கனெக்ட் பண்ணதுக்கு அப்புறம் பார்த்து இப்போதைக்கு ரெக்கார்ட் பண்ணு எப்படி ரைட் So shall we get started? Okay. So as I mentioned, right, in the previous class, we are done with the projectile motion. So also as I informed, I taught you something extra as well. From projectile motion, if you refer my notes, it will be sufficient enough for you to solve any problem from your textbook. Okay, you can work out on your NCERT problems and reach out to me for any doubts. Now, we'll get started with the next important chapter of your mechanics, which is going to be Newton's laws of motion. Okay, so this is the topic, and this is going to be the 5th chapter. Right. So the name of the chapter is Newton's laws of motion. Right. If you come from the beginning, is the cursor there? Yeah. So if you come from the beginning, right, if I have to give you an introduction to this chapter, if you look at the order in which we were discussing the topics, what did we observe? Units and measurements, keep it aside. Then when we came to the concept of motion, we saw about motion in one dimension and motion in two dimension as well. So these are the two topics that we saw, right? So if you observe in these chapters, right, in these chapters, what were the concepts on which we were concerned about? We are only concerned about the motion, but not the cause. So we were concerned about motion, but not about the cause. So this kind of a concept falls under a branch of physics called as kinematics. But the next question that we need to ask is, for any object in this world to move, the most important necessary or the most important or the necessary parameter is force. Right? So if you see, force is always going to be the cause and motion is going to be the effect. Yeah, or else we can call it as result also. So this cause is going to generate this effect. Right? So this we know. But what did we do till now? We were never concerned about what was the amount of force that is needed to push an object, because we never spoke about the mass or any other parameter of that object. If you observe, we spoke only about acceleration due to gravity, but we never spoke about weight of the object. Right? So I'm assuming that these terms are already known to you. Acceleration is different from weight. Right? About all those things we'll be seeing in this chapter. Right? Now, if there is a concept where you are interested to study about motion and the cause, then that falls under the branch of physics called as dynamics. So now we are slowly getting introduced to the concept of dynamics, right? So it is important for us to understand all the nuances clearly, right? So whenever you study any chapter in physics, right, for that matter, any subject, the first thing that you need to know is the basic terminologies that are used. So first, we will start with the terms that are involved in this chapter. The first term that we are going to see is inertia. See, the slide is big, don't worry about it. You need not write everything, I'll just discuss, concentrate. So this is the first and the foremost topic that we need to understand before we enter into the concept of Newton's laws of motion. So what is that we need to understand? Inertia. So let's try to understand what is inertia and what are the different types of inertia. Okay, right. Now, even before I explain, can you people tell me what is inertia according to you? What do you know? This term is not new to you. You would have definitely seen in your lower grades, right? So what is inertia? Sorry? Not change what? Not change what? Inertia is not a force. Okay, can you give me an example? See, let's forget physics. Physics have inertia, okay, physics term. But tell me, like, you're sitting, you're standing, you're walking, everything you're doing, no? What is your understanding of inertia out of it? So what do you mean by that? See, it's an observation of what you're actually doing. See, physics is all about observation. To that observation, they give a special name. That's it. Okay. So here there is something that you already do. There is some property which you already follow. Okay. For that, there is a name given as inertia. That's it. Okay. Don't read the examples there or something. You tell me what is inertia. Your understanding. See, for example, let's say this bag is there. This bag is placed at its position, or else I'll take this remote. I'm placing it here on my hand. So what is the state of this object? It is at rest. So how long is it going to be at rest? Unless we start applying an external force. So here there is an important point we need to focus upon. So this object, I'm able to see that it is going to be at rest unless I'm going to move it literally. What am I supposed to do? I need to take my other hand or something, or I need to move my hand like this to create a motion in this object, right? So when I talk about this object, there are different kinds of forces acting in it. One is, it is made up of atoms, right? So the atoms among themselves are going to interact, and that is happening internally. And the forces that are acting between the atoms, you can call them as internal forces. Internal forces. right? So we call them as intermolecular or interatomic, all those things. I'm not getting into the technical details. I'm just trying to explain that there is something called as internal force associated with this. Now, if I need to move this, who is responsible for its motion? Is it the force that I'm applying or the force that is already there inside? So here, if you observe, mostly to make this object move, I need to apply a force from outside. So that is why, if you see, we mainly speak about force and we speak only about external force. Okay, that is why in this chapter, the first point I wanted to stress upon is we'll be talking only about external force. We'll not be dealing with any internal forces at all. Okay, that is the first point. Secondly, coming back to the concept of inertia. So it is continuing to be in the state of rest unless and until I'm able to apply an external force. And that should do one more thing. I'm applying a force now, but it's still not moving. I need to apply a force which is sufficient enough to put this object into motion. So till then, what is it trying to do to the force that I apply? It is resisting. So by default, every object will tend to resist two things. One is, if it is at rest, it will try to resist to go into motion. It will say, I'm not ready to go into motion. If it is already in uniform motion, I'm not talking about accelerated motion. If it is already in uniform motion, then you need to apply a force to bring it to rest. So it will not say that I will not come to rest unless you apply a force on me. So inertia basically has something to do with the amount of resistance, right? Amount of resistance an object offers to the external force to do exactly the opposite of what state it is. You're able to understand what I'm trying to say. So if it is at rest, it will oppose the external force which is trying to move it. If it is already moving, it will try to oppose the external force which is trying to stop it. So this property is called as inertia, right? So inertia is an inherent property. It is an inbuilt property. It is not something that is given by us. It is inherited. It is an inherent property of that material, right? Inherent property of a material object. By virtue of it, it cannot change. What can it not do? It cannot change by what? By itself. Means if it is at rest, it cannot put itself into motion, which cannot change by itself its state of rest. Or when I'm talking about motion, I'm stressing on one point. What is it? Uniform motion. So I'll come to this point again. Listen to this carefully. The inherent property of a material body, by virtue of it, it cannot change by itself its state of rest or uniform motion, not accelerated motion. Because when I talk an object is at rest, what is the acceleration of it? When I say an object is in uniform motion, what is the acceleration of it? In both the case, the most important point we need to focus upon is, for you to speak about inertia, you need to ensure that the acceleration of the object is 0. So what are the two states possible? State of rest or uniform motion. So to both these states of motion, what will inertia of that material do? What will the property of that material do? It will try to oppose. Is the point clear? So this is what is called as inertia. So the term inertia means resistance to change. I use this word, no, it will try to resist. It is the resistance to change. Okay. So that is what inertia is all about. Now the next question is, if some property of this sort is exhibited by material, then what are the different kinds of inertia that can be exhibited or that is possible? So there are 3 types of inertia. One is called as inertia of rest. Name itself is suggesting. What do you mean by inertia of rest? So you can see. So the tendency of an object to remain in its position of rest. So if an object is at rest, it will try to continue be at rest itself. Okay. So what is the example we can think of? There's a very common example which is given in your textbook, and this you would have experienced also. Right? What is this? So person standing in a bus. Right? There is a person who's standing in a bus. What will happen to him or her when the bus suddenly stops? So there is a person which is standing in this bus. The bus is moving. So inside the bus, the person is at rest, right? He's continuing to be at rest. When there is a sudden jerk, there is a sudden brake that is applied, what will happen to this person? So move. Why? Why are they moving backward and not forward? See, when the brake is applied, it is going to go and stop in the front only. No, why is the person going backward? Because that was the initial position taken by the person at the time of application of brake. Right? When the brake is applied, the bus is still moving. But what is the person saying? I don't want to move from that position. So that position has passed in this direction. You are able to understand the position is actually here, but the bus has passed this. So the person will try to lean back. Are you able to understand this? Right? So this is what happens. So the person will tend to fall backward when there is a sudden application of brake. Right? So the explanation is given here. This might be expected. Okay. So when the bus is moving forward, this is what I tried to tell you. Which part of the body is in contact with the bus? So his legs are in contact with the floor, right? The legs are at rest. So body will also tend to be at rest. I'm saying tend to be at rest, but it is possible or not that we have to see. Okay. When the bus moves, the lower part of his body begins to move along with the bus. That should happen because it is like his legs are stuck to the floor. He's not in the air, right? It is stuck to the floor. So the legs are supposed to move along with the bus. Then what will happen? While what is happening to the upper part of the body? The upper part of the body will tend to continue to be in the rest state itself, due to which there is a relative displacement going to take place between them. That is why this one will be here, but the upper part will start bending like this. Are you able to understand what is this called as? This is inertia of rest. Then what will inertia of motion be? Exactly the opposite. So what is inertia of motion? Which motion? I'm stressing uniform motion. So stress on that point. The tendency of an object to remain in its state of uniform motion in which line? In a straight line is called as the inertia of motion. Okay, here you should not talk about two-dimensional motion. It is only about one-dimensional motion because there is a concept called as inertia of direction. Okay, so the tendency of an object to remain in its state of uniform motion in a straight line is called as inertia of motion. The same example. So when a bus moving suddenly stops, a person sitting in the bus, what happens to them? So if you're suppose sitting in the bus, there is a bus that suddenly stops. What will happen to your body? You will tend to go in the forward direction, right? Because according to the bus, you're sitting, right? You're in motion only, right? Right? When there is going to be a motion, the lower part which is in contact with the seat tends to be at rest, whereas the upper part will tend to go in the forward direction. Okay. So that is the explanation. I hope you are able to understand these 2 points. Right. So you can just make a quick note of those points. Shall I proceed? So what were the inertia of rest and inertia of, so you need not copy the whole story, just put it as a block diagram. So put it as a block diagram like this. First block, person standing in a bus, arrow mark, brakes applied. Okay, then what is happening? So look at the statement. I'll tell you how to take notes. Don't sit and write the whole statement. So what is the first point telling? Person standing in a bus. So that is the subject. From here, what is the next point of the story? So falls backward, right? So falls backward under what scenario? When brakes are applied. So falls backward. So first part is subject, right? Falls backward due to what? So application of brake, that's it. That should be the whole story of this paragraph. You're able to understand? So similarly, take the notes for the second. Don't sit and write the whole story. Shall I proceed? The next question is inertia of direction, right? Inertia of direction. The inability of an object to change by itself, what will happen? Inertia of direction means it will not be able to change its direction by itself, right? So the inability of an object to change by itself its direction of motion is called as inertia of direction. So what is the example we can think of? So when you think of the same bus, when the bus is taking a sharp turn, right? Let's say there is a 90-degree cut that is happening. When the bus is taking a sharp turn, what will happen? You will go in the opposite direction, right? So why is that happening? It is because of the inertia of direction. So if you observe the inertia of motion, it took place in a straight line, whereas inertia of direction is taking place in a curved path. It is going to be, you can call it as two-dimension also, right? So when a bus takes a sharp turn, a person sitting in the bus experiences a force acting away from the center of the curved path. So any idea about what that name is? What is the name of that force? It's called centrifugal force. So force that is acting away is called as centrifugal force. Basically, it is a pseudo force. I'll tell you what is a pseudo force. Okay. So what is the opposite of this? So there is a force called as centripetal force. So centripetal means center seeking. A force which is always seeking towards the center is called as centripetal force. We'll be learning about this also. We'll be seeing the derivation of this, right? So which is called as centripetal force. So let's come back to the point. When the bus is taking a sharp turn, what will happen to the person? The person will be feeling as if he or she is being thrown away from the center of that particular turn, right? And why is it happening? It is happening because of the inertia of direction, right? Have you all experienced this, right? This happens in any vehicle. Here the bus is given as an example. It happens with any vehicle. Shall I proceed? Right.
So centrifuge is away from center.
Sorry.
Centrifuge is away from center.
Centrifugal is called as SCUDO. It's also called as pseudo force. Centrifugal force is a force acting away from the center. Okay. I'll talk about the pseudo force later, because we have not yet got into the concept of forces at all. Okay. See, this chapter actually we can learn practically. There are many things okay, we can do and see. Wherever possible, I'll do an activity and show. Right? Shall I proceed? Okay. See, name of the chapter is Newton's laws of motion. Right? So in your lower grades, you would have learned the different laws of motion. How many laws are there? 3. You already know that, right? But the question is, before you see those laws, right? There are, as I told you, that there are some basic terminologies that you need to understand. Among which one was inertia, and the second most important term is linear momentum. Okay. So this linear momentum is represented by the symbol P. Right. See, before I give you my definition, can you people tell me what is your understanding of linear momentum? What do you know about linear momentum? Okay, because you are using the word linear. Okay, but what is the mathematical definition or definition for it in the first place? Can you visualize it? You already know this, but you would have applied it in many problems also.
Sir, are you asking the formula for momentum?
Sorry?
Are you asking for the formula for momentum?
What is it?
Mass into velocity.
Okay. So he's saying he knows the formula, it's mass into velocity. That is a basic definition also. So linear momentum, as the name suggests, right? Linear has something to do with straight line, right? This word momentum actually means if you have an object of mass m in your hand, right? Let's take this remote itself as an example. Let's say it is given some velocity. What are you doing? You take this, keep it on a weighing scale, you will be able to measure the mass of this. Now, you know the mass of this. If you put it into motion, when I say motion, it is going to have velocity associated with it. If you know the mass of this particle and if you know the velocity of that particle, if you multiply those two parameters, then if I have to give a name to it, that name is what is called as linear momentum. Okay. So linear momentum here doesn't have any significance kind of thing or anything. Linear momentum basically is a parameter which is calculated by taking an object of mass m and by giving it a velocity v. So it is basically like this. It is the product of whom? It is a product of mass and velocity of an object. Okay. So it is a product of mass and velocity of an object. So how do you write linear momentum as P is equal to m into v? That's it. So if mass into velocity needs to be replaced with some parameter, you call it as P. That's it. And first point that we need to make a note here is, since you're using the word velocity, right? Since you're using the word velocity, here linear momentum is going to be a vector quantity, meaning it has a direction, it has a magnitude and a direction, and most importantly, for any vector quantity to be defined, the most important thing we need to get satisfied is it should follow the triangle law of addition of vectors. Not every physical quantity that has magnitude and direction is said to be a vector quantity. Can you give me an example of such quantity?
Time.
Sorry?
Time.
Yeah, time is an example, because time has magnitude, it has a direction, forward direction. Time has a forward direction. You generally don't calculate time in the reverse direction whenever you do an activity, right? So it has a particular direction, either forward or you can say backward. Okay. The best example we can think of is electric current. When you think of electric current, it has magnitude and direction. What is the direction of electric current from your 10th standard basics? Higher to lower potential, right? So still it is not a vector quantity. Reason? it does not follow the vector laws of addition. If that is failing, it is no more a vector quantity. So have this in your mind. Vector quantity should most importantly satisfy the condition of vector laws of addition. If not, it is not a vector quantity at all. So here linear momentum is a vector quantity. That implies P vector can be written as m into v vector. So P is written as a vector. Mass is a scalar quantity. Velocity is a vector quantity. So P vector is equal to m into v vector. Am I clear with this? Right. Now, what is going to be the SI unit for this? Mass is measured in kilogram. Velocity is measured in meter per second. What about the CGS unit? Mass is measured in gram. Velocity is measured in centimeter per second. Now, what about the dimensional quantity of it? Sorry, what about the dimensional formula of it? So it is going to be ml t minus 1. So mlt minus 1. So this is going to be everything about a linear momentum. Okay, and just make a note of it. Is that clear? Shall I proceed? Okay. So before I go to this Newton's law, right? Listen to this. We understood how to calculate linear momentum. Now the question is, how will you calculate inertia? How is inertia calculated? The answer to this is there is no direct formula for it. There is no direct formula. See, suppose I give you a box. Okay. So where this box is made up of cardboard and this box is made up of some stone. Okay. Some rectangular shape. Okay. Here it is hollow. Here it is completely filled. Both are of same volume. Okay. Now I'm asking you to stand here and push those boxes. Which one will be easy for you? Obviously, right? Why is it easy? Because it has lesser mass. So inertia cannot be measured directly. It can only be compared. So how will you compare? More is the mass, then more is going to be the inertia. So from this I can conclude that inertia is directly proportional to mass. Okay. So this can be another question that can be asked. They will ask you, what is the measure of inertia? You need to answer, mass is the measure of inertia. So I repeat, what is the measure of inertia? Mass is the measure of inertia. How is mass related to inertia? Inertia is directly proportional to mass. So more is the mass, more is the inertia. That's it. Clear with this? Okay. Now, next, we will get into the topics of this Newton's laws of motion, right? So when we talk about Newton's laws of motion, there are three laws associated, of which what is the first law? So the first law states that every object continues to be in the state of rest or uniform motion until and unless there is an external force applied on it, right? Unless and until you apply some external force on it to change what? To change the state of the object. If the object is at rest, by applying external force, you'll put it into motion. What kind of motion? See, if an object is at rest, right, initial velocity is 0, you apply a force. It will attain, let's say this force is sufficient enough. Now, what is going to happen to this? This object is going to attain motion. What kind of a motion will this be? It will be non-uniform motion. Because once you start applying force and acceleration are related. So what do you mean by non-uniform motion? It is going to accelerate, right? It is not a uniform motion. So when force is applied on an object and the object is going into motion because of that force, of whatever state it is in, whether it is at rest or whether it is going to be in the state of uniform motion, when force is applied on an object and motion is caused because of it, that motion will always be non-uniform motion. In a similar way, there is, let's say, a ball that is moving on a horizontal surface, which is having friction, right? It is moving with a constant velocity v. So as soon as the friction comes into picture, what will happen? Where will the friction act? It will act along the ground. So when the friction comes into picture, what will it try to do to this velocity? It will try to stop it. So how is it going to stop? Is it going to bring the value from v to 0 instantaneously, or it will slowly decrease and come? So can I say that the object is going to decelerate, right? So whenever this friction or external force is coming into picture to stop an object which is already in uniform motion, also the motion is going to be non-uniform motion. Are you able to understand why it is non-uniform? So where to use uniform and where not to use uniform? Yes. When is it? I think I've already arranged for a feature and we took it, no? If you wouldn't ask questions from how many more topics are? Which topic? Units and measure. That is the last topic, dimensional form. But did you learn the three methods which needs to? Okay, Raj, I'll arrange it. I'll arrange it. Can you just put it in the number which I tell you? Just write down the number. That number which is there outside 93615 93615 89909 09. Can you tell the number? 93 So drop a message in there. Okay. Shall we proceed? So if you observe, this law states that every object continues to be in the state of rest or uniform motion unless and until an external force is applied on it. And this law, if you observe, it is similar to the definition of inertia. So this law is also called as law of inertia. So we call it as law of inertia. How many of you have tests next week in school? You also have a? You also have. Next week, Onakilla? So what are the chapters?
Sir, only percent.
Okay, but motion and straight line we have completed, no? Vectors is not there. That is there. Okay. What about you? You have this chapter. Okay. Then you will be knowing this. So others are from DAV only. For you, the no test next week. Over. For you? Over. So what did you say? Units and measurements and motion in a straight line. Only these two. Okay. But how come vectors you have only cross product and dot product, the basic? Was the derivation shown, or you know the derivation of dot product and cross product, why the values are coming like that? Like for example, if two vectors are given, you know how to do dot product, how to do cross product. You will put those two lines determinant method. Okay. Next. So the next concept that we'll see is Newton's second law. So Newton's second law speaks about the relation between force and linear momentum. So what is that you would have learned? You would have learned F is equal to ma, right? So you learned this F is equal to ma, but how did this come in the first place? This was not stated by Newton. He directly didn't speak anything related to acceleration at all. What was it spoken about? If you observe one thing, right? When an object is at rest or in uniform motion, that is a previous law. So when you talk about the object being at rest or in uniform motion, what are the two parameters spoken about? Rest speaks about initial velocity being 0. Uniform motion speaks about initial velocity being a constant. If you observe, this is what is spoken about. Here we didn't speak anything related to acceleration, but velocity fortunately can be related to acceleration. That's what we derive a mathematical equation in the second law. But try to understand one point here. See, all that I'm talking here is important for your assertion reason based questions. At that point, if you need to answer these questions, you need to know the stories. Okay. So u is equal to 0 or u is equal to constant speaks only about velocity. Right. Now, if I take this u and this u, just multiply it with mass, what do I get? So if I say that initially the object is at rest, what is going to be the linear momentum of the object? 0. If I say that the object is in uniform motion and the object's mass is also a constant, then what is the kind of motion? It is going to be uniform motion and the momentum is going to be constant, right? It is having a constant linear momentum, right? Now, if you observe, when you put an object into motion, what should happen? Let's say initially the object is at rest, you apply some force. So as soon as you apply some force, what is going to happen to its velocity? It will go from 0 to some non-zero value. Accepted. Right, u is equal to 0, it will go to some v. Let's say it takes time t for this to happen. Okay, it takes a time of t units for this to happen. Let's say the object's mass here is m and here also it is m. By you applying a force in this direction, you're creating a linear momentum in that direction. So can you tell me what is going to be the linear momentum here? It is going to be m into v. What is the linear momentum here? So can I say P initial is 0 and P final is going to be m into v? Can I say this? Okay. Now, the second law states that the rate of change, what do you mean by rate? So rate is something changing with respect to time. So the rate of change of linear momentum of an object is directly proportional to the applied force. So when you apply an external force, it is observed to be directly proportional to whom? Delta P divided by delta T. What does delta stand for? Change. So delta P means change in linear momentum by change in time. Right? So when you remove the proportionality symbol, you get K times delta P by delta T. But through dimensional analysis, it was observed that the value of K is equal to 1. Okay. So when it is going to be 1, then what is going to be the external force that is acting on it? It is going to be delta P divided by delta T. So what is the value of delta P here? Can I say final can I say it is final linear momentum minus initial linear momentum divided by final time minus initial time. So what is the final linear momentum? It is going to be m into v, right? Minus what is going to be the initial momentum? 0 divided by what is going to be the time? T minus 0. Right. So can I write this as m into v minus 0 divided by t? So what is the change in velocity with respect to time? Acceleration. And this is how you get F is equal to ma. Okay. So here one thing that we need to observe is the mass of the object is constant. There will be some scenarios where the mass of the object will change. For example, rocket propulsion. When the rocket is going upwards, the fuel is getting utilized, right? Due to which the mass of that vehicle will keep changing with respect to time. So there you will not be directly taking out this m and using it. There we need to deal it in a different way. We use calculus. Okay. So this is generic derivation where you can say that the external force acting on the object is equal to mass into acceleration mathematically. Okay. Just make a note of this. Right. Should I proceed? And the last one, and a simple one, which is the Newton's third law. So what does it state? To every action, there is always an equal and opposite reaction. Okay. To every action, there is going to be an equal and opposite reaction. Right. See, suppose I take a fixed surface like this, on which, let's say, there is a block of mass m kept on top of it. There is a block of mass m kept. Okay. Now, what is going to be the force that will act on this mass M? Can you tell me what are all the forces that will act? See, let's take this itself. So if I take this to be the block, right? If I remove my hand, what is going to happen to this? It will fall. It will fall because of its own weight. I wrote it as mg. Mg is called as weight. Remember it. How did I directly write it as mg? For mass into acceleration. Acceleration here is g. So that is why I wrote it as mg. Now this mg will apply a force on the floor in the downward direction. Right? What will the floor try to do to this mass? It will create a reaction force. Why is it so? Because the system is at rest. So when there is an action, according to this law, there should be an equal and opposite reaction. What do you mean by equal? Equal in terms of magnitude and opposite in terms of direction. So there is an equal and opposite force that is going to act on the object. And I call that reaction as R as of now. R stands for reaction. I'm not going to tell you what that reaction name is. Okay. So according to this mathematical statement, what I can state is every action has an equal and opposite reaction. So mg is equal to R. Make sense? Yeah. It's not G, it is mg. Right. Clear with this? Right. So these are the three laws of motion. Let's come from the beginning. What was the first law? So it's called law of inertia. What do you call them as? So any object continues to be in the state of rest or uniform motion unless and until an external force is applied on it. Second law. Is directly proportional to the applied force on it. Third, every action has an equal and opposite reaction. Right? No. So, since we understood that F is equal to mass into acceleration, now we will see the different kinds of units that are followed, out of which one is called as absolute unit of force and the second is called as gravitational unit of force. Okay. So the absolute unit of force is that force which produces a unit acceleration in an object of unit mass. So what is the meaning of this is, I write F is equal to ma, right? Right. If I take m is equal to 1 unit and a is equal to 1 unit, if I take this 1 and 1 substituted here, then F will be equal to how much? 1 unit. So I didn't write which unit here because we are going to discuss about SI and CGS. So understand this concept. In SI system, what will happen is, in SI system, when you try to define the absolute unit of force, it is going to be Newton. And we know that whenever you are writing a unit in an expanded form, you should always start with lowercase. Okay. Whereas if it is the name of a person, you should always write it in uppercase. That is why if you see for Newton, it is not written with capital N-E-W-T-O-N. It starts with lowercase only. That is an important point to be noted. Okay. And 1 Newton is defined as, observe this statement and tell me what should happen. 1 Newton is an absolute unit of force. 1 Newton will act on an object of how much mass? 1, not unit, 1 kilogram, because I'm defining it in terms of SI. In SI system, what is the unit of mass? Kg. What is the unit of acceleration? Meter per second square. So 1 Newton is defined as that much force which produces an acceleration of 1 meter per second square on an object of mass 1 kilogram. You're able to understand actual what is the meaning of it? So 1 Newton is basically written as mass, that is 1 kilogram, into acceleration 1 meter square. So 1 into 1 is obviously 1 kilogram meter per second square can be replaced with the term Newton. So kilogram meter per second square is replaced with Newton. So what unit is this? Absolute unit. Second point is, if the same force is defined in terms of CGS system. What is CGS? Centimeter gram second. If it is defined in that kind of a system, then the absolute unit of force is going to be dyne, dyne, right? Right? So how is one dyne defined as? One dyne should be a force that is acting on a mass of 1 CGS system, mass of 1 gram, creating an acceleration of 1 centimeter per second square. You're able to understand? So 1 dyne is that much of force which produces an acceleration of 1 centimeter per second square on an object of mass 1 gram. So 1 dyne is equal to 1 gram into 1 centimeter per second square. So 1 into 1 is 1 gram centimeter per second square can be written as dyne. So to put it simple, in SI system, what is the unit of force? What is the absolute unit of force? Newton. In CGS system, what is the absolute unit of force? Is dyne. Okay, so make a note of it. So shall we proceed to the next one? Okay. Sure. Done? So next point that we are supposed to see is gravitational units of force. Okay. So previous one was absolute unit. Now it is gravitational unit. So as the name suggests, right? So gravitational unit of force is that force which produces an acceleration equal to g. So in the previous case for absolute unit of force, how much should be the value of acceleration? It should be 1 unit. Whereas for you to define something in terms of gravitational units of force, how much should be the acceleration that should get produced? It is not 1 unit, it is 9.8 meter per second square or 980 centimeter per second square. To put it simple, it should experience the acceleration due to gravity, right? But how much should be the mass of the object? The same unit mass in an object of unit mass. So to put it simple, it can also be defined as the weight of an object of unit mass. So I gave you the formula for weight. What is it? mg. In the place of m, if I put 1, right, this f is equal to mg, right? So in the place of m, if I put 1, then what will I get? I'll just get g. So here f is equal to g, but still it will have a unit associated, right? So based on that, we are going to define 2 units. One in terms of SI and the other is in terms of CGS. Okay. In SI system, the gravitational unit of force is going to be called as kilogram weight. So what is the weight of 1 kilogram mass is what we are going to see. So it is also called as kilogram weight, or you write it as kgWT, or sometimes it is also written as kilogram force. Okay. This is another important unit that you need to know. What is it called as? I repeated, the gravitational unit of force is called as kilogram weight or kilogram force, or it is also called as the weight of unit mass, unit kilogram mass, right? So it is defined as that much force which produces an acceleration of how much? In SI system, what is the acceleration g? 9.8 meters per second square. It should produce an acceleration of 9.8 meters per second square on an object of 1 kg. So if you take these two parameters and put it here, then 1 kilogram weight will be equal to 1 kgf will be equal to how much? 1 into 9.8. So how much will the answer be? 9.8 kilogram meters per second square, but kilogram meter per second square in absolute unit can be replaced with Newton. So that is why wherever you see a question where they give you the unit in terms of 1 kilogram weight, if you want to convert it to Newton, what are you supposed to do? 1 kilogram weight, if you want to convert it to Newton, multiply that kilogram weight with 9.8. That will give you Newton. For example, if there is an object of 5 kilogram, if there is a force of 5 kilogram weight, if I ask you to convert it to Newton, what will the answer be? 5 into 9.8 Newton. So if you want to remove that kilogram weight, multiply it with 9.8 and write it as Newton. Okay. Whereas in CGS system, what will happen? In CGS system, the gravitational unit of force is called as gram weight or gram force, right? It is that force which produces an acceleration of, this time it should produce only an acceleration of 980 centimeter per second square. It's very simple, okay? See, 9.8 meter per second square, 1 meter is how many centimeter? 100. So if I put 100 here, 100 into 9.8 is 980 centimeter per second square. Both are same only. Because the definition, we are still sticking to the point saying that it should be acceleration due to gravity, right? So in CGS system, the gravitational unit of force is called as gram weight or gram force. It is defined as the force which produces an acceleration of 980 centimeter per second square on an object of how much mass? This time it will not be 1 kilogram, it will be 1 gram because it is CGS. Okay. So 1 gram weight will also be equal to 1 gram force. It should be equal to 1 into what will you substitute in the place of G? You will put 980. So gram centimeter per second square is going to give you. So basically what I'm doing in CGS system is 1 into what is the gram? What is the acceleration due to gravity? 980 centimeter per second square. This is 1 gram. So what is gram centimeter per second square called as? Dyne. So this will be equal to 980 dyne. Are you able to understand? Shall I proceed? You copy? Okay. Okay. So we saw 2 units of force. What were they? Absolute and gravitational. In absolute, what was the SI unit of force? Newton. What was the CGS unit? Dyne. Similarly, in gravitational unit of force, SI was kilogram weight. Kilogram weight, and CGS it was gram weight or gram force. Right. Now, the important question that we need to answer is how will you convert anything given in Newton to Dyne and vice versa? Right. So 1 Newton is basically, Newton comes from the absolute unit of force. So 1 Newton is how much? 1 kilogram meter per second square. 1 dyne is 1 gram centimeter per second square. See, whatever I'm going to explain now is the same thing applicable in dimensional analysis as well. So understand, there's one such application of dimensional analysis, that is finding the value of 1 unit in terms of other. So what I will do is, I'll convert everything from SI to CGS. So observe, 1 kilogram is how much? 10 power 3 gram. 1 meter is 10 power 2 centimeter. So since here it is second square, I'll leave it as second square only. So what will this be equal to? This will be 10 power 5 gram centimeter per second square. So basically 1 Newton is equal to 10 power 5 gram centimeter per second square. But what is 1 gram centimeter per second square called as? Dyne. So what I can conclude is 1 Newton will be equal to, it will be 10 power 5 dyne. Or you can say 1 dyne is equal to 10 power minus 5 Newton. So depending on the problem, you can convert one from the other, one to another, right? Done? Okay. Listen. So that's the relation. No? So now we can try out some simple problems that are based on Newton's second law. Okay. So a car of mass 1000 kilogram is moving with a velocity of 10 meter per second. So mass is 1000 kilogram and velocity is equal to 10 meter per second. And it is acted upon by a forward force. It is acted upon by a forward force of 1000 Newton due to engine and a retarding force. So for retarding force, I'm using small f. Okay. Retarding force of 500 Newton. The question is, what is going to be the velocity of the object after a time of 10 seconds? Okay. The whole data is in the same line. So let us visualize it diagrammatically. So there is a force acting at this direction of how much value? Of 1000 kilogram. And there is a friction that is acting is of value 500 Newton in the backward direction, right? In which direction is the velocity maintained? In the forward direction, because that is the direction in which the car is moving. Okay, one correction here. Force is 1000 Newton. So this 1000 Newton is there, 500 Newton is here. So mass of the object is 1000 kilogram, right? Now tell me one thing, we need to find the velocity of the object. After how much time? After 10 seconds. So if I take v to be the final velocity, can I convert this to be the initial velocity? So this is the initial velocity at t is equal to 0, at t is equal to 10 seconds, it is v. So what does Newton's second law state? The external force acting on the object is equal to mass into v minus u divided by t final minus t initial. Or I'll write it like this. Listen. Can I write it as change in linear momentum by change in time? So this will be how much? M into v minus u divided by t minus 0. The change in time is how much in this problem? 10 seconds. 10 seconds. So here the question is about F external. For F external, should I take 1000 or 500? I should take 1000 minus 500. So the point to be noted here is this is the net force. Okay, the point to be noted is it is not the only external force, it is the net external force. This is the sigma value. Okay, so if since the object is moving in the rightward direction, I'll consider the forces in the rightward direction to be positive. So 1000, that 1000 force should overcome the force of 500 Newton to create this much acceleration. This will be equal to mass of the object is 1000 into final velocity is what I need to find minus what is the initial velocity, 10, the whole divided by 10. So this is going to be 500 is equal to 1000. I can cancel this. So it is going to be 100 into V minus 10. So this is going to go 5 times. So V will be equal to 15 meter per second. So first thing is you need to validate whether this is right or wrong. This is right. There is a possibility of this being right because the velocity has increased. So it means that the object is accelerating. Are you able to understand? Suppose the retarding force was greater than this, your answer should have been negative, and this value should have been less than the initial value. So you need to do these kind of validations also. You can find the acceleration and then you can apply V minus U. Okay, then you can apply V minus U. That should also work. I hope it is simple, right? Okay. So I can copy this. Will that copy? You people do this with an NCERT program.
Sir, is it minus 270?
Did you say minus 270?
Yes, sir, minus 270.
Maybe. Can anyone else confirm? Don't look at your books. Use your brain. Do it. Question, but answer. It's only one formula. Do it properly. V is equal to U plus 8. Try to solve. So take down the data. So I'll just give you a hint. Had they not given the mass of 0.04 kilogram, this problem would have been a problem belonging to previous chapter. So if had the mass not been given, they would have not asked you what is the retarding force. They would have asked you what is the deceleration. Okay, then it would have been a kinematic problem. So to the kinematic problem, generally they give you mass and ask you force, right? It will become a dynamic problem. So to put it simple, the procedure is same. So if I call it as an SOP, standard operating procedure, it is the same. You need not break your head. All that you need to do is find the acceleration that will come out as negative value. Multiply that with mass, that will give you the force. Just do that. Can you do it? Find the deceleration. So what is the initial velocity of the object? It's there, be confident, 90 meters per second. After it enters the wooden block, what is happening to the bullet? So final velocity is 0. So how much distance is it traveling? 60. So there is a formula that connects V, U, A and S. What is it? V square, apply that, you will get the answer. Got it? What is the answer? I think that's the answer. That's what he told. I think 270 is the answer. Negative. Resistive, obviously negative. So those who didn't understand can look at the board. The second problem is a bullet of mass 0.04 kilogram moving with a speed of 90 meters per second. So initial velocity, so mass of the object is 0.04 kilogram. Initial velocity is going to be 90 meters per second, enters a heavy wooden block and is stopped after a distance of 60 centimeters. So 60 into 10 power minus 2 meter or 0.6. Both are same. Now what we need to find is, we need to find the average resistive force is how much. For that, find the acceleration. A is equal to V minus U divided by T. So V is 0. So whenever the final velocity is 0, the object is only going to decelerate. So 0 minus 90. Oh, sorry. Yeah. So correction. Applying the formula, V square minus U square is equal to 2AS. Right? We get A is equal to V square minus U square divided by 2S. V square is 0. So it is 0 square minus 90 square divided by 2 into, what is the displacement? It is 60 into 10 power minus 2. So this you can write it as minus of 90 into 90 divided by 2 into 60 into 10 power minus 2. So 0 and 0 are gone. This will go 3 times. This will go 2 times. This will cancel this 45 times. So 45 into 3 is 135. So 135 by 2 is going to be 67.5 into 10 power 2 with a minus sign. So 6750 meter per second square is going to be the amount of deceleration it is experiencing, retardation. Right? So since you want the resistive force, what you need to do? So take the mass 0.04 and multiply it with 6750. So 0.04 into how much is it coming? It comes out to be 270 Newton, and obviously there's going to be minus because of the resistive force. Okay. So it is going to be minus 270 Newton. Okay. There are 3 more problems. So we can start with one more problem tomorrow and then go to the next set of topics. So tomorrow I'll be discussing a very important topic, which is called as free body diagram. I'll tell you how free body diagram. I'll tell you how to solve any problem based on Newton's law. Okay. I hope it's clear. Any questions? Those are online. Any questions?
No, sir.
No,
Is everyone clear? Ananya and Shweta, both are clear?
yes, sir.
Okay, then we'll wind up.